All right, so this is going to be section 2.2 continued. So last time we looked at piecewise functions in picture form, and so I wanted to look at them, what they look like in equation form. So I think we were on example 4 for today. So when you have a piecewise function, it's going to have the g of x format, but it's going to have like a curly brace there. Okay. And the curly brace implies that everything inside this braces is going to be a part of that function. So this is an example of what a piecewise function might look like. We might use the pattern 3x plus 2 if x is less than 0. Okay. But then we might switch to the pattern of 2x plus 1 if x is greater than or equal to 0. So piecewise functions in equation form look like this. Okay. They have the curly brace to indicate that, hey, there's more than one thing going on with this. Okay, and when x is less than 0, you use pattern number 1, and when x is greater than or equal to 0, you use pattern number 2. Okay, so I can ask you much of the same questions that we were answering with function notation before. So let's say I asked you to find the following. Okay, so g of -4, g of 2, and g of 0. Now remember, function notation with a number inside the parentheses just means what? What do you do with that number? You plug it in, right? The question here is like, which one do we plug it into? Okay, and the answer is not both. You never ever plug it into both, because then, by the way, it wouldn't be a function. You would have one x value paired up with two different y values. So we don't plug it into both, but what you do, for instance, when you're trying to find g of -4, is you ask yourself, you pay attention to the fact that x is -4, and you ask yourself which category it falls under. So is -4 less than 0, option 1, or is it greater than or equal to 0? Okay, and of course -4 is what? Less than 0. Okay, so we're going to use equation 2. I'm going to abbreviate equation EQN. So we're going to use, equation 1, okay, and we're using equation 1 since -4 is less than 0. Okay, because the value we have falls in this category. Yes?
I can't really see that up there.
Okay. Maybe you could try that desk over there. I mean, I can't make it any larger than that. Well, like which part? You saying the red maybe is no good? Oh, okay, yeah, I'll switch to another color. I thought you meant all of it, and I was like, oh, I don't know. I don't know how to make it so much bigger. Yeah, I'll use purple or something. That'll be a little darker. All right, so we're going to use equation number 1. So we'll do 3 times -4 plus 2. So we'll get -12 plus 2 or -10. Okay, by the way, this is still going to be like it was before. This is the y value when x is -4. Okay, so we're still finding function values there. All right, so let's try the next one that I asked for, g of 2. So again, before we do the plug-in step, we have to ask ourselves, like, which equation it would be appropriate to use. So we have, put that away, we have x is 2, right? So which category is that going to fall under? Is 2 less than 0, or is 2 greater than or equal to 0? It's greater than or equal to 0, right? So I need to use equation number what? I need to use equation number 2. So since 2 is greater than or equal to 0, I use equation 2. So I'm just going to plug it in. So -2 times 2 plus 1. So I get -4 plus 1 or -3. Okay, so how would you describe -3 then? We're not going to write it down for this one, but it's the what? It's the y value when what? When x is 2. Okay. So then lastly, g of 0. Notice 0 is maybe the trickiest one, right? So which category are we in? So you're going to need to make sure you remember how to read less than, greater than symbols. This means plain old less than. This means what? What does it mean when there's a bar under it? Greater than or equal to 0, right? So if we're greater than or equal to 0, then which category should we be using? 1 or 2? 2. So we're going to use equation 2. Okay. Since 0 is greater than or equal to 0. Okay. In other words, we use the one that includes 0, and that's option number 2. So if we do -2 times 0 plus 1, we get 1. Okay. So definitely you don't plug it into both. You make the decision before you do the plug-in step, like which equation is it most appropriate to use. Okay, so let's practice one where maybe the functions are a little, maybe a little more complicated or a little bit more to them. So let's say the first pattern is this fraction, x plus 2 over x minus 2. And the second pattern is actually pretty simple, it's just 5. And then let's say I want you to find these two. Find, not f, sorry, h of 5 and h of 3. So just like the one before it, we just need to make a decision on which equation we're going to use ahead of time. Okay? And it all has to do with whatever the value of x is for that part, right? So what's the value of x for this first one? The value of x is what? 5, okay? So I have a little different if statements here, so let's read them. How do you read that right there? Like something with a slash mark through it, what does that mean? Not equal to, right? So anytime we're not equal to 3 for the x value, we're using equation 1, okay? Only when x is equal to 3 do we use equation 2, okay? So if I ask you to find h of 5, my question is 5 not equal to 3 or is 5 equal to 3? 5 is not equal to 3, right? Which means I need to use equation number what? I need to use equation number 1. So I need to plug it in everywhere there's an x, so I would get 5 plus 2 over 5 minus 2. So I end up getting 7 on top, 3 on bottom. If you can simplify it, do, but notice 3 doesn't go into 7, so that's as far as we can go with it. Okay, but if you get something like 2/4, for instance, make sure you reduce it to 1/2. My math lab is going to want the reduced answer. All right, but what about h of 3? Remember, h of 3, when x is 3, is the only time we use equation 2, right? So if you look, right, notice we're here, right? X is actually equal to 3 this time, so we're going to use equation what? 2. And so there's not really much to equation 2. What's the answer when we're using equation 2 no matter what? The answer is just 5. It's not like you multiply 5 times the number, like it's just the answer is 5. Okay, there's no variable there, so there's nothing to plug in really. Okay, so typically you're going to see piecewise functions for this class anyway that have just 2 options, but you can have piecewise functions that have 3 options. So when you're kind of setting this up, maybe make this like 3 spaces tall, like 3 lines tall. So here's the first expression. It's 0 as long as x is less than -4. It's negative x if this inequality holds true. I'm going to talk about that in a minute. So for now, just write that down.
Although you took attendance, do we still need to scan to come in?
That's like for the university, so that's optional. So they're doing that for contact tracing, like, so that's not required. So I don't use that to determine attendance like I use my own attendance. But that's how they're going to do like contact tracing if you were happen to be in a class with someone who tested positive, then that's how they're going to notify you. But that won't really apply to us much because we're sitting 6 feet apart. Like we're not doing group work or we're huddled together, you know what I mean? So that's actually, yeah, that's the university. And I'm technically supposed to do it, but I forget. So if you want to do it, you can, but it's not a requirement. It's supposed to be a way they can know who is where at what time. But I mean, it's going to be dependent on everybody remembering, and so it's probably going to be pretty unlikely. Okay, so before we start, I want to read through this and make sure we know how to say these. The first one is x is less than -4, right? The third one is x is greater than 0, but this one might look weird to you, so I wanted to make sure we were clear there. So it just literally it means what it kind of looks like. X is sandwiched in between -4 and 0. So that's what it means. Anything between -4 and 0, including -4, but not 0. That's what it means. Okay, so just like it looks, it would mean anything in between them on the number line. Okay? So what kind of things are between -4 and 0? Things like -3, -1, right? So think about a number line if you're kind of struggling with that. But these are the things I want you to find. So we're going to find 4 function values this time. So g of -2, g of 1, g of -6, and g of 0. So again, we do not ever, ever, ever plug these numbers into more than one thing. You need to make the decision on which equation to use before you begin. So for g of -2, you just need to kind of go down the list, okay? So is -2 less than -4? No, right? -2 is not less than -4, right? Is it in between -4 and 0? It is, right? So which equation should we be using then? Equation 2? Okay, so we use equation 2 and it's pretty simple, right? It's going to be negative and then -2. So notice the equation has a minus sign in it, but then the x we're plugging in is negative. So what is a -2? Positive. Okay, what about g of 1? So again, we kind of go through the list, right? 1 is not less than -4, right? So it's not the first category. 1 is not in between -4 and 0. Is 1 greater than or equal to 0? It is, right? So I need to use which equation? Equation 3? Okay, so in other words, my plug-in step looks like 1 squared or 1. Okay, g of -6. So again, just go through your list, right? So which category does -6 fall in? Is it less than -4? Is it between -4 and 0? Or is it greater than 0? It's less than -4, right? Which means I should be using what? Equation 1? So not a whole lot to equation 1, though. What's the answer if you're using equation 1? Yeah, the answer is 0. Okay, and then what about g of 0? So this is one that's kind of, you have to pay attention, right? So which one of these, because it's one of these, right? Which one of these includes 0 and which one doesn't? So this one's just less than, right? It doesn't include 0, but this one is what? Including 0, so we'll use equation 3. Okay. Note that if we square 0, we're still going to have 0, right? Okay, so all of these are just the y values we get with these various x values, and again, you just have to make that choice on which equation to use at the beginning. Okay, so we've been talking about functions. So another kind of category that I want you to be able to classify functions in is the following. We can show whether functions are even, odd, or neither. And this is going to have some graphing significance for us later. So there are 2 ways to show this. I'm going to mention both of them, but then I'm going to tell you which one I want you to know probably more so than the other. So you can show it algebraically. That's going to be our go-to. And you can also show it graphically if you know what it is you're looking for. But I'm putting a star by algebraically because if I had to pick something that I'll probably include on test 1, it would probably be the algebraic format as opposed to the graphic format. Okay, so first things first, how do you tell if a function is even? It's a little bit more than you're looking for even numbers, okay? But a function is even. If a function is even, then the following will be true. Your original function f of x will be the same as f of -x, okay? So this is what my MATLAB / your textbook says. I like to explain it kind of in everyday language. So in other words, we're going to replace x with -x. By the way, that's what f of negative x means, right? It's telling you to plug in negative x for x. So if you replace x with negative x in the equation, and then you simplify it, and if the new equation equals the old equation, then it's even. So here is how I'm going to want you to be able to prove it to me. So let's take an example. So I want you to tell me, is x to the fourth plus x squared, that should be a 2, sorry, plus 1 even? So it should be x to the fourth plus x squared plus 1. I just messed up on my squared there. So we can certainly figure out a guess, okay, but as far as showing it, we actually need to do what I said in the parentheses. We need to actually find out what x, or f of negative x is. So here's the process for showing your work. So what does f of negative x mean? It means I need to go to my f equation. Sorry, there should be an equal sign there. That'll make more sense, right? So f of x equals this guy right here. So what does f of negative x mean? It means go to your f equation and do what with that negative x?
Plug it in for every x.
Yeah, plug it in everywhere there's an x. So I'm going to get negative x in parentheses to the fourth power plus negative x in parentheses squared, and then plus 1. Okay, what we're trying to do is figure out if this new equation gives us the same thing as we had originally. But before we do that, go ahead and simplify. In other words, what is a negative something times itself 4 times? Like, it's going to be x to the fourth power, right? But my point is it's going to be a negative times a negative times a negative times a negative, okay? And when you have an even number of negatives, what happens to the sign? It becomes positive. So this is x to the fourth. And then same thing here, right? If I do a negative x times a negative x, it's a positive x squared. And then notice nothing happens to the plus 1, okay? The point is to compare what you get to the original. And what do you notice? If you compare them, what do you notice? They are the same, right? So if they're the same, what does that imply then? Yeah, so f of x is even. If they're in any way different, it means that they're not even. Okay. All right, so let's look at odd, and then I'm going to talk about kind of my math lab and how I want you to practice this on my math lab. So here's how we're going to describe odd functions. So if a function is odd, then f of negative x, in other words, the result we get when we plug in negative x, is actually the negative version of the original. Okay, so again, this is what my math lab / your textbook will tell you. But here is the gist. You're going to do the same thing you did for even. You're going to replace x with negative x in the equation and simplify. Notice so far it's the exact same method. So the method for showing even or odd is one and the same. It's really just a matter of what you get as a result. So if the new equation is exactly the negative version of the original, then the function is odd. See if I can make it full screen there. All right, so let's do an example with odd. So you need to be really, really careful about your signs on these because actually your signs are the gist of what we're doing here. So is g of x equal to x cubed minus 2x odd or not? So our process for showing this is, again, to find g of negative x. So this will be a good practice of that function notation anyway. So notice that means everywhere there's an x, what do I need to do? Yeah, plug in negative x. Okay, and then I need to simplify. Okay, that's a big step. Make sure you simplify. So the same kind of logic, what would happen here if I multiply a negative x times itself 3 times?
Positive x cubed.
Well, maybe not. Think about negative times a negative times a negative. That's only 3. So actually, what would it end up being?
Negative.
It'd actually be negative, right? If it were an even number, it'd be positive, but it's an odd number, so it's negative. So we get negative x cubed. Okay, what about here? What's negative 2 times a negative x?
Positive.
Positive, right? Okay, so then again, we compare what we get here with what we started with. Okay, and what do you notice? It's definitely not even, right? Because it's not the same as what we started with, okay? The question with odd, though, is it the negative version of the original? In other words, did all the what?
Signs choice.
Yeah, did all the signs change? And notice they did. All the signs changed, which means it is the negative version of the original. Hey there. So that means that g of x is odd. Okay, so one more example. This is going to be more like what I would ask on a test, and this is going to be more like what my math lab will ask you. So rather than just straight up asking you whether it's even or asking you whether it's odd, it's going to ask you which of the 3 it is, because it can't be more than one of these, okay? Now, we haven't talked about neither, but it's kind of implied, right? When would it be neither? When it's not even, and when what? It's not odd. When it's not one of those, then it's neither. Okay, it's just by default going to be neither. Okay, so let's say this is the function I want you to compare. So x cubed plus 5. Okay, so how am I going to show what it is or what it's not, maybe? I'm going to find what? For both types, I need to plug in what for x? Negative x. I need to find f of negative x. Okay, that needs to be your process. So I'm going to plug in negative x everywhere there's an x. Notice the 5, I don't do anything with that. Okay, there's nothing to plug in for that 5 term. Okay, so kind of like we did on the last one, what kind of sign are we going to get if we have 3 negatives? It's going to be 3 negatives would be a what? Negative times a negative would be positive, but then times 1 more would be a negative, right? So it's going to be, this last one's cubed, x cubed.
Thank you.
Okay. All right, so we get negative x cubed plus 3. Okay, and then we're going to do what? We're going to compare this back to the original. So we're just going to kind of run through our options here. Okay, it is not even. Why is it not even? So the question even should be if they are exactly the same, right? So is what we get exactly the same as what we started with? No, right? So I'm going to say it's not even because they're not the same. Okay, so let's move on to odd. So is it odd? It's close, but I would say it's not odd. How come?
Is it odd, is still positive?
Yeah, everything didn't change, right? So I'm going to say it's not odd either. And it's because not all the signs changed. The 5 stayed the same. So it was really, really close, but what are we going to have to say since it's not even and it's not odd? It's neither. Okay, so do you see how I say that are going to be really, really important here, okay? It was one little sign that threw this off and made it not odd, okay? It was the +5 not changing, okay? All right, so before we move on to something different to talk about what these look like in graph form, I want to talk about my math lab. Now, my math lab for these questions is going to give you like a multiple choice type option for you to choose even, odd, or neither, okay? So can you just go through and just make a random guess and just hope you get a 1 out of 3 shot chance that you're right? The answer is yes. I'm not going to know that you did that, okay? But remember, your homework doesn't count for that much in this class. So I'm trying to tell you how I'm going to expect you to show it on a test, and that's what matters a whole heck of a lot more than homework. So try to do your homework like I'm telling you that you'll have to do it on a test, okay? So again, I'm not really going to know if you kind of cheat the system that way, but you're really not cheating anyone other than yourself, okay? Because later on, it's going to come back to bite you when you have to take a test about it, okay? So this is the method that I want you to show. If you had a high school teacher or some other teacher show you a method that involved plugging in a positive version of a number and a negative version of a number, that is not enough to show even, odd, or neither. So if you don't know what I'm talking about, you can ignore that statement, but if that makes sense to you and you remember a teacher teaching you that, just know that that's not an acceptable way of showing even, odd, or neither. That only shows it for one number. It doesn't show it for everything, but our method shows it always, okay? All right, so that's how you algebraically determine even, odd, or neither. You plug in negative x and you see what happens, okay? So you can also show it graphically if you know what you're looking for. I don't highlight this way because frankly, not all of us have graphing calculators. I know I recommended that we have one, but I didn't go so far as to require it, so I don't know that we're always going to really have access to the graphs, but I still want you to know it, okay? And so here's what's true about even functions. Even functions, I'm going to kind of squeeze this in because I'm going to do two side by side here, have what we call y-axis symmetry. Okay, symmetry just means it's the same on one side versus the other side. So let me give you an example of a simple function that is symmetrical, okay, or has y-axis symmetry rather. If you draw y equals x squared, y equals x squared is even, okay? And the reason that it's even graphically is because notice what the y-axis does to it, okay? Doesn't it have y-axis symmetry? In other words, doesn't the y-axis cut it in half vertically? Okay, so that's really what it means. So if it has y-axis symmetry and you have a graph and you know what the graph looks like, then you can just kind of quickly say, well, I know that's going to be even. Okay, so what's the implication? What if it doesn't have y-axis symmetry? What can you know that it's not then? It's not even, yeah. All even functions have y-axis symmetry. Okay, on the other hand, odd functions are a little harder to describe visually. So odd functions have what we call origin symmetry. Okay, so it is not quite as easy to eyeball and tell. Okay, and that's another reason why I don't really focus super hard on the graphic representations. So let me give you a function that is odd, and we'll talk about what origin symmetry looks like. X cubed equations look like this. They curve up one way and down the other. So this is the graph of y equals x cubed, and it is odd. So notice how this looks. This is how all origin symmetry graphs look. It almost looks like you took this piece and kind of rotated it around 180 degrees. Like I said, it's not as easy to tell origin symmetry as it is to tell y-axis symmetry. Okay, so you can either think of it this way, but this is what's known as origin symmetry. So maybe an explanation, you can think of it this way. You can rotate the halves by 180 degrees, okay? Or some people like to think of it like reflecting it, or reflecting the halves over both the x and the y-axis. It just, to me, basically looks like one half is the rotated version of the other. That's how I tend to talk about it. So what that means is like this piece, if you flipped it around, you get that piece. Okay, but another way to think of it is a double reflection. So in other words, if you folded this way and then folded it that way, you get that too. Okay. So again, origin symmetry is harder to pick out. I think y-axis symmetry is going to be a lot more obvious. Origin symmetry, you might have to think about just a little bit. Okay, but if it has origin symmetry and you can tell that, what do you know about the function? It's odd. Okay, and if it doesn't have that kind of symmetry, so let's finish this off. So basically, neither functions have neither of these types of symmetry. It doesn't necessarily mean they won't be symmetrical. It means they won't be these kind of symmetrical. So I want you to focus mostly on the method where you use the algebraic version where you plug in negative x, and then secondarily maybe know how to look at the graph.